How many different outcomes will you be able to make with 4 shirts, 5 jeans, and 5 shoes? 4 times 5 times 5. 4 times 5 gives us 20, and then times 5 will give us 100. So we'll have 100 different outfits to pick from. All right, finding the probability of a compound event. So what we've done so far is just found the possible outcomes. But when we're finding the probability of a compound event, we're trying to figure out what's the likelihood that it would occur. So we are going to use the formula. The probability of the event equals the number of favorable outcomes, so what makes that true, over the number of possible outcomes. So the probability of a yellow shirt. So if you look over here, we have 2 yellow shirts. One's just a little bit lighter. So we have 2 yellow shirts over our 1, 2, 3, 4, 5, 6, 7 possible shirt options. Then we have blue pants. So we have 4 pairs of pants, but only 1, 2, 3 of them are blue. And that's going to be over the total amount of them, which would be 4. And then the probability that shoes with orange, so the only pair of shoes that have orange on them is our 3rd pair. We have 1 pair of shoes with orange over our 3 total. And so now we want to figure out what the probability is that I would pick a pair or an outfit that would have yellow shirt, blue pants, and an orange with my shoes. So all you do is you take all 3 of your fractions and you're going to multiply them together. And that's using that FCP that we just learned in the last video. So we have 2 out of 7 shirts that are yellow. We have 3 out of 4 pants that are blue. And we have 1 out of 3 pairs of shoes that have orange on them. And so we just multiply straight across. So 2 times 3 times 1 gives us 6. And then we have 7 times 4 times 3. And that gives us 84. So if I was to simplify this fraction, I have 6 over 84. So we have the number of favorable outcomes and the number of possible outcomes. And when I simplify the fraction, I get 1 out of 14. So 1 out of 14 outfits will be a yellow shirt, blue pants, and orange with my shoes. So to figure out my percent, we learned this last chapter, but we just do our top number divided by our bottom number. And so our top number divided by our bottom number, so 1 divided by 14 gives us 0.071, and then it goes on for a while. And you'll get that same decimal if you were to just do 6 divided by 84. You get the same thing. So you'd get that same exact decimal. And so it doesn't matter which one you use, but we just need to turn it into a percent. So we're going to move that decimal 2 times to the right. So we get 7.1, or about 7.1%. So about 7% of the time we meet the requirements of having a yellow shirt, blue pants with orange on our shoes. So I want you to pause the video and try it on your own. And then when you're ready, I want you to check your answer with mine. So go ahead and pause it now. All right, so we said the probability of rolling a die, which has 6 sides, and getting a number less than or equal to 4. So there's 6 total sides on our cube, on our die, and then a number less than or equal to 4 would mean that I can have numbers 1, 2, 3, and 4. So I have 4 options, which is the same as 2/3 of the time. And then heads, so when I flip a coin, I have 2 options, heads or tails, and I would get heads 1 out of the 2 times. And so now I'm going to multiply them together. So it doesn't matter which one you use, the simplified fraction or the regular fraction, you'll get the same thing. So I'm going to use our original, so 4 out of 6 times would I get a number less than 4 on a die, and 1 out of 2 times I would get a heads when I flipped a coin. And so now I'm just going to multiply straight across. So 4 times 1 gives me 4. And then 6 times 2 gives me 12. So to get that percent, I'm going to do 4 divided by 12. And when I do that, I get 0, point, and then a bunch of 3s. They're just going to go on forever and ever and ever. So I'm going to turn that to a percent by moving that decimal 2 places to the right. So I get 33.3, and we're going to say repeating percent. So that means about 33% of the time I will get a number less than 4 and flip heads, or less than or equal to 4. And to prove this to you that we'd have 4 out of 12, I'm just going to, off to the side here, show you that on a die, I have the numbers 1, 2, 3, 4, 5, 6, and then I have heads or tails for each of those. So I can have heads or tails and roll a 1, heads or tails and roll a 2, heads or tails and roll a 3, heads or tails and roll a 4, heads or tails and roll a 5, and then I have heads or tails and roll a 6. So if you count these off to the side, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 possible outcomes. And to make it true, the number has to be less than or equal to 4. So that means that I can roll a 1 and flip heads, and that would be true. I can roll a 2 and flip heads, and that would be true. A 3 and flip heads, or a 4 and flip heads. But I can't roll a 5 and flip heads because it doesn't make this true, because I want the probability of it being less than or equal to 4 on the number cube. So that gives us 4 out of 12 possible options, which then would lead us down to that 33.3 repeating percent.